When the person is having a blurred vision, then it is difficult for that person to make the exact measurement. There are three ways to express the magnitude of errors, and they are absolute error, relative error and percentage error. We have to take the difference between each and every individual quantity with the mean quantity, and the magnitude of the result is called as absolute error. The formula to calculate relative error is mean absolute error divided by arithmetic mean of all the measurements. Hello everyone, welcome to session 3 of chapter 2, Units and Measurements. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we had discussed about the measurement concepts such as the measurement of length, the measurement of mass, measurement of time, and also about errors. So what are errors? Every measurement will be having few uncertainties in it, and those uncertainties in the measurement is called as errors. And we have also discussed about the types of errors. In today's session, let us study in detail about the sources of the errors what we have discussed in the last session. Yes, as we discussed in the last session, there are two types of errors. One is the systematic error, the other one is the random error. What is systematic error? So, what are the types of systematic error? There are three types we have in a systematic error, that is the instrumental error, imperfection in the experimental technique, and also personal error. So, these are called as the source of systematic error. So, today we are discussing about the source of systematic error. Yes, first one, it is instrumental error. As the name says, instrumental error. We need an instrument to measure any quantity. If there are any uncertainties in the instrument, if there are any design problems, if there are any mistakes in the calibration of the instrument, and it is called as instrumental error. Yes, it is due to imperfect design or the calibration of the measuring instrument, such as zero error in the instrument, and that is called as instrumental error. So what is this zero error or the calibration? The concept called zero error you are going to study in your practical sessions when we are studying about the vernier calipers and the screw gauge. So here, for example, if you want to know what is zero error in case of vernier calipers, I can show this example. We have a main scale in vernier calipers instrument and also a vernier scale. So this is called as vernier scale and the upper scale is the main scale. Here in this example, we can find the difference between the first division of the main scale and also the first division of the vernier scale, which means the instrument is having certain errors. Yes, instrumental error is one of the major source of systematic error. And next we have imperfection in the experimental technique. And the name itself, it is defining the source of this error, which means imperfection in the experimental techniques. These type of errors, it is due to the drawbacks of the experimental arrangement, or we can say that due to limitations of experimental arrangement. Yes, for example, when you consider a simple pendulum experiment, in calculation of time period of simple pendulum, the error arises due to the air resistance which is present in the surrounding. Yes, due to air resistance, we can observe certain dissimilarities in the readings what we take when we are performing the experiment. Yes, this is one of the example to understand the imperfection in experimental technique. The limitations or the drawbacks causes these type of errors. Next we have personal error. So, personal error, what does it mean? These type of errors are due to individual bias, the person's individual bias, the error due to carelessness of a person, the error due to person who is not concentrating in experiment. Yes, personal errors may arise due to lack of attentiveness, or it may be also due to the bad sight. When the person is having a blurred vision, then it is difficult for that person to make the exact measurement. Yes, such type of errors are called as personal errors. We are discussing about systematic error and the sources of systematic error, the instrumental error, imperfection in the experimental technique, and the personal errors. These three are the sources of systematic error. Yes, then how this type of errors can be minimized? How can we minimize the systematic errors? Yes, the systematic errors can be minimized by improving the experimental technique and selecting better instruments with good calibration and design and removing the personal error or improving the personal errors, we can minimize the systematic errors. Okay, next we have random error. The next type of error is called as random error. So what is this random error? Again, the name itself is defining what it is. Yes, these are the errors due to unknown causes and they are called as random error. Sometimes while performing the experiment, we may notice the first trial reading will not match with the second reading, what you get in a second trial, and that is not matching to the third reading, what we get in the third trial. That is due to various reasons. There may be some unknown reasons as well. So these type of errors or the difference what we get in taking the readings, they are called as random errors. And these random errors can be minimized by repeating the measurements again and again and taking the average or arithmetic mean of all the readings to get the correct reading. Which means, suppose if we are getting different values in many trials, we will not be able to consider which is the true value. Which means the different values contain some error. So we can minimize this just by taking the average of all these things, and hence we can consider it as a true value. In random error, we have least count error. So what is the meaning of least count error? The term least count itself defines, that is, the least or the lowest measurable value with the help of that particular instrument. In any instrument, least count means the least measurable value that can be done by that instrument. Yes, least count error is nothing but the error associated with the resolution of measuring instrument. So how these errors can be minimized? So least count error can be reduced or minimized by using the instruments of higher precision and improving the experimental techniques, and also by taking the average of all the readings. These type of random errors or the type of random error that is least count error can be reduced. We have discussed about what is an error, what are the types of error, and what are the sources of these errors. Now let us discuss about the error calculation. There are three ways to express the magnitude of errors, and they are absolute error, relative error, and percentage error. So what is this absolute error? What is relative error? What is percentage error? How can we calculate the magnitude of error? By these three ways. So the first one is absolute error. How to find absolute error? Yes, the magnitude of difference between the individual measurement and the true value of the quantity. So if we have several quantities, we'll take an average of those quantities. So the average of those quantities will give us the mean value, and that is called as the true quantity or the true value of the quantity. So in the calculation of absolute error, it is very important to first take the average of all the given quantities, and hence we'll consider it as true value of the quantity. Only when we have the true value of the quantity, we can take the difference between each and every individual quantity with that true quantity will give the absolute error. Let us understand this by taking one example. Suppose the values obtained in several measurements are A1, A2, A3 and so on up to AN, which means we have n number of values, and I call it as A1, A2, A3 and so on up to n values we have. Now we have to calculate the absolute error in each quantity. So how to calculate the absolute error in each quantity? As the definition says, we have to take the difference between the each and every individual quantity with the mean quantity, and the magnitude of the result is called as absolute error. So the arithmetic mean of these values is taken as the true value or the best value of quantity under the given conditions of measurements. So let us now calculate the best value or the best possible value of the measurement, that is denoted by A mean, which means we are taking the average of all the quantities we have. We have A1, A2, A3, A4 and so on up to n number of quantities. So I am taking it as A1 plus A2 plus A3 plus A4 plus and so on up to AN, divided by we have n number of quantities. In taking average, we have to divide the quantities with number of quantities. Here I have number of quantities, so I am taking it as A1 plus A2 plus A3 and so on up to AN divided by n. Now, the absolute error in each values can be calculated, and the absolute error is denoted by delta A1. So, absolute error for the first quantity delta A1 is equal to, as the definition says, the difference between individual measurement and the true value. Here, this is nothing but true value. So, true value is A mean. So now we have to take the difference between individual measurement and the true value. The individual measurement is, first one we have A1 minus the true value, that is A mean, and delta A2, that's absolute error in the second measurement, which is equal to A2 minus A mean. And similarly we can write delta A3 is equal to A3 minus A mean, and similarly delta A4 is equal to A4 minus A mean. So similarly, we can find it for any number of quantities, and hence conclusion, and hence we can write delta an is equal to an minus a mean, that's for nth number. So this is nothing but absolute error. This is how we have to calculate absolute error. The magnitude, only the magnitude I am talking about, the magnitude of the difference between the individual measurement and the true value of the measurement is called as absolute error. Now we know how to calculate absolute error. Now after getting all the absolute errors of different or each and every individual quantity, now we have to find the mean absolute error. How to find mean absolute error? It is nothing but the arithmetic mean or the average of all the absolute errors is called as mean absolute error. Yes, it is nothing but delta A mean, which is equal to, here you can observe we are writing the magnitude of absolute errors. We have to write the quantity or the absolute error within the modulus, so that it is nothing but we are considering just a magnitude, plus delta A2, that is absolute error of the second quantity, plus delta A3, plus and so on for n value divided by whole divided by n gives us mean or the arithmetic mean of all the absolute errors. Here this refers to absolute error of quantity 1. So here we are taking the average, we have to sum all the absolute errors divided by number of absolute errors, give us the arithmetic mean of absolute errors, and that is called as mean absolute error. Next we have relative error. So what is this relative error? I told you there are three ways to express the errors. One is absolute error, the other one is relative error, and the other one is percentage error. So what is relative error? How can it be calculated? The ratio of mean absolute error and the mean value is called as relative error. So in the beginning, here in this example, we have calculated the mean value of the quantities, right? So this mean value, again I am talking there in the relative error, and the relative error is given by, it is nothing but the ratio of mean absolute error to average mean or arithmetic mean of all the quantities. So this A mean we have calculated in the beginning, and delta A mean is nothing but the mean absolute error, what we have studied in the last slide. So by taking the ratio of these two quantities, we can find the relative error in any measurement. So next we have percentage error. The third way to express error is percentage error. So when the relative error is expressed in terms of percent, then that is called as percentage error. Relative error is represented by delta A mean divided by A mean, and when that is represented with a percentage, then that is called as percentage error. We can express the error in terms of percentage by multiplying the relative error with 100. So we will get the error in terms of percentage. Let us now understand this with the help of a simple example. Here I have 4 values, the measurements: 2.4 meter, 2.5 meter, 2.7 meter and 2.4 meter. These 4 are my values or the measurements. Now let us calculate mean absolute error, relative error, and let us express this in percentage error as well. So before calculating the absolute error, we must find the average or the arithmetic mean of these quantities. So take the quantities, the 4 quantities we have, that is 2.4, 2.5, 2.7 and 2.4 again. So to calculate these mean value of these measurements, just add everything and divide it by number of quantities we have. We have 4 quantities. So 2.4 plus 2.5 plus 2.7 plus 2.4 divided by the number of quantities we have is 4. So you add everything and we will get 10 in the numerator and we have 4 in the denominator, and the true value, by taking the ratio of this, we will get the answer 2.5. That is our mean measurement or the average of these measurements. Now we have to find absolute error. How to find the absolute error? I told you it is nothing but the magnitude of difference between the individual measurement and the mean measurement. So here the individual measurement is 2.4 and the mean measurement or the arithmetic mean is 2.5. So 2.4 minus 2.5 gives us minus 0.1. But we have to consider only the magnitude in case of absolute error. So we are taking 0.1. We are neglecting negative sign here. And next we have 2.5. Here also we have mean measurement 2.5. Taking the difference, the answer we get is 0. So the absolute error is nothing but 0. Next measurement we have 2.7 and the mean of this measurement is 2.5. 2.7 minus 2.5 is 0.2. Again, the absolute error in this measurement is 0.2. We have 2.4 again. 2.4 minus 2.5 gives us minus 0.1. Since we have to consider only the magnitude, the absolute error in this measurement is 0.1. Now we got absolute errors of all the measurements. So after getting the absolute errors, it is so easy to get mean absolute error. That means we have to add these values 0.1 plus 0 plus 0.2 plus 0.1 and divided by the number of quantities we have. We have only 4 quantities here. So divided by 4, which is nothing but 0.4 divided by 4, and the mean absolute error is 0.1. I hope now it is easy to understand what is mean absolute error, what is absolute error, and how to calculate relative error. Yes, after finding the mean absolute error, we can calculate relative error, because the formula to calculate relative error is mean absolute error divided by arithmetic mean of all the measurement. So delta A mean value is 0.1. So 0.1 divided by the average value of measurements is 2.5. So 0.1 divided by 2.5, which is nothing but 0.04. Next, we have to represent this error in terms of percentage. Percentage error can be calculated by multiplying the relative error with 100. Now we have relative error, that is 0.04. So 0.04 into 100 gives us 4%, and that is the percentage error. This is how we have to calculate the absolute error, mean absolute error, relative error, and also percentage error for any measurements. So let us solve one more example in calculating this absolute error, mean absolute error, and also percentage and relative error. We have a question: refractive index of water in different trials of experiment is found to be 1.31, that is A1, that is 1.31, 1.33, 1.32 and 1.34 and 1.36. These are the different measurements we have. Now we have to calculate mean refractive index, the absolute error, relative error, and percentage error in refractive index. So these are the refractive indices of water in different trials. We need to calculate the mean of this refractive index and also the error that is present in these measurements. So let us do it now. Now we have to calculate A mean value of these quantities. So which means it can be calculated as the average of these quantities can be calculated as 1.31 plus 1.33 plus 1.32 plus 1.34 plus 1.36 divided by the number of quantities I have is 5. So just add all the quantities divided by number of quantity will give you the arithmetic mean value. So if you had these quantities divided by 5, you will get 1.332, and that is the mean value of these measurements. Now, after calculating mean value, we have to calculate absolute error. So how to calculate absolute error? It is nothing but the difference of individual quantity minus the mean quantity. So the first one we have 1.31 minus 1.332. So the answer we get 0.022. Here, since 1.31 is lesser than 1.332, we will get minus 0.022. Here we have to consider only the magnitude, and hence I am writing 0.022. That is absolute error. Next we have 1.33 minus 1.332, and the difference we get 0.002. Here 0.002 is the absolute error. Next we have 1.32 minus 1.332. Now take the difference, 1.32 minus 1.332, and the difference is 0.012. Next we have 1.34 minus 1.332, and the difference you get is 0.008. Next 1.36 minus 1.332, you will get 0.028. So these are the absolute errors, and now you have to calculate mean absolute error. So mean absolute error is denoted by delta A mean. How to calculate the mean absolute error? It is 0.022 plus 0.002 plus the next value 0.012 plus 0.008 plus 0.028 divided by number of values we have 1, 2, 3, 4, 5. So divided by 5. So the answer we get is 0.0144. So this is the average of these absolute errors, and that is called as delta A mean, which is nothing but 0.0144. Now find relative error. How to find relative error? So relative error can be calculated as delta A mean divided by the mean value or the average value of the measurements. So delta A mean is 0.0144 and the average value of all the measurement is 1.332. The answer you get for the relative error by taking the ratio of the mean absolute errors and the mean value of the measurements 0.0108. Now percentage error. How to calculate percentage error? That is representing this relative error or multiplying this relative error with 100, that gives you percentage error. So we have relative error 0.0108 into 100, we will get 1.08% of error in this measurement. So in this example, for all these measurements, there is an error of about 1.08%. Combination of errors. In that, first we have error of sum or a difference. When two quantities are added or subtracted, the absolute error in the final result is nothing but the sum of the absolute errors in the individual quantities. For example, if we have A and B as two quantities, then how to find sum? Let us say Z is equal to the result of the sum of these two quantities. So Z is equal to A plus B. The error in that measurement, that is Z, which is nothing but delta Z. Delta Z is nothing but the error, the absolute error present in the final result, which is equal to sum of absolute errors of the individual quantities. So we have the quantities A and B. Delta A is nothing but the absolute error of this quantity A, and delta B is nothing but the absolute error of the quantity B. So in the final result, find the absolute error in the final result, we have to take the sum of absolute errors in the individual quantities. Yes, even in subtraction, for example, Z is equal to A minus B, we are subtracting the two quantities called A and B, and delta Z is nothing but the error that is present in the final result, the absolute error that is present in this final result, which can be calculated by adding the absolute errors of two quantities. Though we are subtracting, we need to add the absolute errors of the individual quantities, and that is called as error of a sum or a difference. Yes. For example, we have A value, that is 5 plus or minus 0.1, and B value 2 plus or minus 0.2. We have two quantities called A and B. Now we have to find the sum. We have to find the resultant of two quantities. We are doing the sum. So which means we need to add the things. So 5 plus 2 gives us 7. Here 0.1 and 0.2. Here these two are the absolute errors. Which means we need to add these absolute errors since we are performing sum. So absolute errors gets added up and we will get 7 plus or minus 0.3. This in case of sum, it's common. That is, we are adding the two quantities. What in case of subtraction if you are considering? So subtraction, we have two quantities again the same values, 5 plus or minus 0.1 and 2 plus or minus 0.2. So here we are subtracting and hence you have to subtract these two values. That is 5 minus 2 will give you 3. But though you are doing subtraction, the absolute errors in the individual quantities should be add together. So we have to add 0.1 and 0.2 and we have to write plus or minus 0.3. Next we have the error of a product or a quotient. So we have discussed about sum or a difference. Now we are going to study about product or a quotient. When two quantities are multiplied or divided, the relative error in the result is the sum of relative error in the multipliers. So in the previous case, we have studied about the absolute error. Now we are talking about relative error. Relative error is nothing but delta A mean divided by A mean is what we have learnt. So let us now see how to write the expression for this error of a product or a quotient. When two quantities are multiplied or when two quantities are divided, their relative error in the result is the sum of relative error of the individual quantities or the sum of relative errors in the multipliers. Yes, multiplication suppose we are doing, A and B are the two quantities we have, Z is the result. So Z is equal to A into B. If the measurement is having certain errors, so delta Z by Z is the relative error in the final result and that is equal to the relative error of the individual quantity, that is delta A by A, that is the relative error in the first quantity called A. Delta B by B is the relative error of the second quantity called B. So in the multiplication or division of combination of errors, it is nothing but the relative error in the final result is nothing but the sum of relative errors in the multipliers. Yes, now this in case of multiplication. Let us now see what it is in division. So A and B are the two quantities. I am dividing A by B and the error present in the final result, that is delta Z by Z, that is the relative error in the final result is which is equal to delta A by A, the relative error in the first quantity A plus the relative error in the second quantity B, that is given by delta Z by Z is equal to delta A by A plus delta B by B. So let us understand this by taking an example. Suppose I have a value A is equal to 5 plus or minus 0.1 and B is equal to 2 plus or minus 0.2. Then Z is equal to, we have to take the product, means we have to multiply these two values, that is 5 into 2, we will get 10. Now, how to find the relative error in the final result? The relative error is given by delta Z by Z, which is equal to the relative error of the first quantity, that is 0.1 divided by 5 plus the relative error in the second quantity, that is 0.2 divided by 2. Now take LCM for these two, we get 10 and numerator we get 0.2 plus 1.0 and the result is 0.12. So we have delta Z by Z, that is the relative error in the final result is 0.12. So 0.12 into the value ZV is calculated already, it is 10. 0.12 into 10 gives you 1.2. And this is the absolute error present when the two errors are combined or multiplied. So now let us see all these combination and the equation all together. So if we are performing sum of two quantities, then the equation is Z is equal to A plus B and the error calculation delta Z is equal to delta A plus delta B. Similarly for subtraction, we are doing the operation subtraction and hence we are writing the equation Z is equal to A minus B and the error can be calculated as delta Z is equal to delta A plus delta B again. Next in multiplication, the operation we are doing is finding the product, so Z is equal to A into B and the error can be calculated, that is the relative error that can be calculated by this expression delta z by z, which is equal to the sum of relative errors in two individual quantities, that is delta a by a plus delta b by b. And also in division, z is equal to a divided by b, and the relative error in the final result, that is delta z by z, which is equal to sum of the relative error of individual quantities, delta a by a plus delta b by b. What if the operation is in terms of powers? For example, the equation z is equal to a to the power n, then the error can be calculated as delta z by z, that is the relative error in the final result, which is equal to n times the relative error in the individual quantity, that is n times delta a divided by a. So these are the expressions to find the error in various operations. So in today's session, we have learnt in detail about the sources of error, the how to minimize these errors, and the calculation of error, and also the combination of errors. So in our upcoming sessions, I'll come up with some more interesting concepts like the significant figures and the rounding of concept, and also the concepts of dimensions. Until then, all of you please take care. Thank you.